Hi everyone, welcome to this video lesson. This lesson will cover inverses. So to create an inverse, what we do is we switch the x and the y coordinates. Okay, so we need to find the inverse R of each relation S, then determine whether the original relation or relation S and the inverse R is a function. So a relation is a function if the x values in the domain do not repeat. We could say this if and only if. Okay, so that would be a more correct to say. So that would be a more correct way to say it. So that means if and only if. So what I am going to do is I'm going to follow what I said here. I have the relation S, and I'm going to take each one of the x values and the y values, and I'm going to switch them at each point. So then all we have to do is on the first point, this is for -1, then becomes -1, comma 4. The same here, this is 6, 1, then switch it to 1, 6. And the next one is -2, 3, so let's make it 3, -2. And the next one is 3, 1, so switch it to 1, 3. And the last one is 1, -2, then let's make it -2, comma 1. So there we have the relation R, which is the inverse of the relation S. So then let's answer these questions. Is the relation S a function? Not a function, so we have to circle one of the two. Okay? So then look at the relation S. This is 4, 6, -2, 3, 1. We don't see any x values repeating. Therefore, we can say with certainty that this relation S is a function. Now we look at relation R. So in relation R, we see -1, 1, 3, 1. So notice this one and this one repeats. So 1 goes to 6 and 1 goes to 3. So that means the x values in the domain repeat, but they cannot repeat if it is a function. So then we say that the relation R in this example is not a function. All right. Okay, the next one. What if you're given a table? Well, same thing. You're going to switch the x and the y values. So then this becomes -6 is the x value and -2 is the y value. And then this is -1, 5. So then this becomes 5, -1. This is 0, 4. So now this is 4, 0. This is -1, 3. So 3, -1. And last, 2, -6. So this is -6 and 2. So now let's look at the relation S on the table. So do we see any x values repeating? Yes, we see -1 and -1 repeating here. So therefore, we know that the relation S is not a function because -1 repeats in the domain. Okay, now let's look at the relation R. The relation R, we see -6 goes to -2 and also -6 goes to +2, which means this is not a function again because the x value of -6 repeats in the domain. So neither S nor R are a function in this example number 2. All right, so let's move on to the next section of the lesson. So on the next section, we need to graph the relation and its inverse from problem 1. So this is number 1. So what I'm going to do is I'm going to plot each one of these points. Okay, so I'm going to pause the video so I don't take too long on this video. I'm just going to plot these points, or maybe I'll do a few. Yeah, I'll do it on the video. So for -1, so this is 1, 2, 3, 4, down 1. Let's see. S with dots, so I'm going to do S with dots, and then R I'm going to do with X's. So the next point is 6, 1. So this is 1, 2, 3, 4, 5. There's no 6, so I'm going to go out a little bit, and I'm going to go up 1. So this is the second point. The next point is -2, 3. So this is 1, 2, up 1, 2, and 3. And the next point is 3, 1. So this is 1, 2, 3, up 1. And the last point is 1, -2. So this is 1, down 2. So there we have the point, all the points of the relation S. Now let's do the relation R. I'm going to do this with red so you can tell the difference. Okay, so you're able to tell the difference. So this is -1 and then up 1, 2, 3, and 4. So I'm going to do this one with X's. And then 1, 6. So this is where X is 1, Y is 6 out of the grid here. So let's say about right there. And I'm going to do an X. And then 3, -2. This is 1, 2, 3, down 1, 2. So this is that point. And then 1, 3. So right 1, up 3. And then last, negative 2, 1. So this is negative 2, positive 1. Okay, so there we have the relation S and its inverse, the relation R, for the first example. So what I am going to do is, I'm going to show you something else, and that is that all inverses are symmetrical across the line y equals x. So I am going to sketch the line y equals x, which passes through the origin and has a rise of 1, run of 1. Okay, so it crosses the x-axis and the y-axis at the same point, or at the same location. So this is that line y equals x. So what this is saying is, see how this point is across from this point, the same distance, and the same goes with this point. So the point is all the points are across the same distance from the line of symmetry, which is the line y equals x. So and it says draw a dotted line, but I hope it's the same thing. The idea is the points are the same distance from this line. So let me just erase some spaces here so that I follow the instructions of what the paper is saying. Okay. All right, so that's all for this example. Let's move on to example number 4 and number 5. So for this part, it's the same idea, to find the inverse equation. So now we have equations, we don't have coordinates, we don't have tables, we have function itself, or functions themselves. So to find an inverse equation, we are going to switch, okay, the variables and solve for y. Then state the inverse equation as, since this is a function, if the inverse is a function, then we use this notation. So we say f, the way you read this is f inverse of x. Okay, so I'm going to write that down for you in a moment. So that's how you read it, f inverse of x. Okay, this notation. So with that said, I'm going to switch this to y equals. Don't forget f of x equals, it's the same as y equals. So I'm going to say y equals 7x minus 4. So then I'm going to switch the x and the y variables. So then this instead of x becomes y, and that equals 7 instead of x. This is now y minus 4. So notice all I did was switch the x and the y from positions or locations on the equation. So now what I need to do is I need to get the y by itself, right? So then I'm going to add the 4. So plus 4 here. Now don't forget, we cannot combine the 4 and the x because they're not like terms. So then I'm going to keep the x and then add 4 to it. And now we have 7y by itself on the right hand side. Since I want the y by itself, I'm going to divide by 7, and I'm going to do that to each term. Okay, we have 3 terms here. So then x over 7, this is implied to be 1x. So I'm going to write this as 1 over 7, because then you can see the slope. X plus 4 over 7 is equal to y. Now, keep in mind, the graph of this function is a line, right? Because even, you see it here, it's a function. This means it's a function. You can't use this notation if it isn't a function. So therefore, since this is a function and the graph is a line, the graph of this one is also a line, because the slope is 1 over 7, and then the y-intercept is 4 over 7. So then since we know this is a function, I'm going to use this notation here, okay, which is f inverse of x is equal to 1 over 7x, which is the slope, plus 4 over 7, which is the y-intercept, the value of b. And when you graph it, don't forget for the x-intercept, the y-intercept, I'm sorry, the x value is always 0, so then the y-intercept coordinates are 0, 4 over 7. Okay, so there's one example. So I'm going to do one more example. Same process, I'm going to switch f of x equals to y equals. So then this is x plus 3 over 2. So then what I need to do next is I need to switch the x and the y. So then this becomes x equals y plus 3 over 2. And then the goal is to get the y by itself. So there is an implied 1. Okay, there's an implied 1 under x. Or you could also just multiply by 2, but I'm going to do what I've said in class, but you can do this different ways. So I'm going to multiply 1 times y plus 3. 1 times y is y, 1 times 3 is 3. So then this is y plus 3 equals 2 times x. That's 2x. Then I'm going to subtract the 3. So then we have the y by itself, and y is equal to 2x minus 3. So then, since I know this, the graph of this one is a line, I mean, if you can rewrite this one, this is the same as 1/2 x plus 3/2. I don't know if you guys can see this, because this is x over 2, which is 1 over 2, and this is 3 over 2, so that's the 3 over 2. So this shows you the slope. The slope is 1 over 2, so rise of 1, run of 2, and then the y-intercept is 0, comma 3/2. Okay, since we know this is a function, this is a line. If you graph it, the slope is 2, rise of 2, run of 1, and the y-intercept is 0, negative 3. So that means this is a function. So f inverse of x is equal to 2x minus 3. And that is all for this lesson. Thank you for watching. I'll see you in the classroom. Bye-bye.